Hello, welcome to your first Geography 231 tutorial. This is going to be a slightly truncated one because we'll already had our live face-to-face Zoom session by the time you see this. So for those that have already taken my 232 class, you were here in the spring, so you know this is sort of it's going to be about the same thing, where I will walk you through at least a portion of a lab, if not the entire the beginning. If it's a three-part lab, I might do the first part with you. Today's is going to be a two-part, so we'll do the first part, or more or less the majority of the first part of the first 1A assignment, and you'll do 1B on your own. And the purpose of that is basically just to show you how, if there is a difference between the text and the software today, I can sort of guide you through the differences, because the textbook we're using was published a couple of years ago, and we'll be using the latest version of ArcGIS Pro. So with that said, I want everyone to know that we'll be using Understanding GIS, the fourth edition, which is designed specifically for ArcGIS Pro. We'll be using this for the first couple of weeks of class, and then we will be switching over to making spatial decisions using ArcGIS Pro. So if you took 232 with me in the spring, or you happen to take it with Eric in the past, you should already have this book, but just know that we're not going to use this initially. So if you don't have it yet, it's okay, but you do need to get this one ASAP. The good news is I'm holding up physical copies, but you can use the ebooks just as well. And considering this is an online class, if I were a student, I would just access the ebooks. They're less expensive. You can use them on your computer screen or on a tablet, on your phone, whatever's easiest for you. So just to bring everyone up to speed on this specific lab, Understanding GIS, an ArcGIS Pro Project Workbook, basically has you inhabit the role of a GIS analyst working on a project for the city of Los Angeles. So I want to make sure that everybody actually reads the intro portion to the chapter, or to the textbook itself, under lesson 1. It's called Frame the Problem and Explore the Study Area. I'm not going to read it right now, but I want you to make sure you spend a couple of minutes reading the first few pages of the chapter, because it really kind of sets the scene for what we'll be doing for the first couple of weeks of class. Ultimately, it's about creating a park along the Los Angeles River, or multiple parks. And so the assignment here has you, as a GIS analyst, going through a series of tasks that ultimately have you choose criteria that you'll use in GIS to pare down potential sites that meet each of these criteria. The park guidelines, this is on page 7, say that the park needs to be on vacant land, all right, at least 1/4 acre in size, within the city of Los Angeles limits, as close as possible to the Los Angeles River, not in the vicinity of an existing park, in a densely populated neighborhood with lots of children, in a lower income neighborhood, and where as many people as possible can be served. So ultimately, the goal is to serve as many people as possible in the city of Los Angeles, preferably those in low-income areas with a lot of kids. So it's obviously a fairly real-world applicable type assignment. So make sure you read those initial pages, and so you can pause the video now if you want, read up on it, and then we can pick up together on exercise 1A. And so I'm going to go through the majority of 1A. I'm not going to do the entire thing with you, but I'm going to walk you through the majority of it, and it will be good to follow along the video, simply because, as I mentioned before, there are a few differences between what's printed on the page or the digital book, which if you get the newer version of the book, this may not be an issue, but my version, there were a few things that have changed since the book came out. So first thing you're going to want to make sure you do is download the data. So you can either do a search for Understanding GIS book resources. So if you Google it, you should be able to find the data from Esri. But I've also uploaded it to Canvas. So if you go onto Canvas, let me see, make sure I can show you here. So assuming you can see the screen, I haven't actually proved that yet. Go to the Files section of Canvas, and then you will see under, I think it would be Unfiled, there should be a zip file called ugis4setup.zip. So download that zip file, unzip it, 228 megabytes, save it to your hard drive, and then Actually, it's not available. It's not viewable yet to U.S. students, so we'll have to make sure that's viewable by the time you see this video. So you're going to need that data before you can do this lab. Okay. So again, go ahead and pause the video, download the data. Make sure you obviously, hopefully, have internet. If you're watching this, you do. Broadband would help download that data quickly. Once you have that, you're going to want to sign in, and we will have already signed into ArcGIS Pro together in our Zoom session on Tuesday night. Everybody should already have your credentials to log in. You should already have access to ArcGIS Pro and ArcGIS Online. You only have to sign in once. So we sign in together as a class on Tuesday, and when you open up ArcGIS now, ArcGIS Pro specifically now, you should already be logged in. So that's not an issue. So that means you can basically skip the very first step, which is log into ArcGIS Pro. It's already done for you. So then you're going to be signed in. And then here's really the first difference between what we have in the book versus what we have on the software. So the software says to create a new project and click blank. We actually have lost the option for a blank document. It's now just called Start Without a Template. But to kind of follow the flow of the book, we're going to do it slightly different. We're going to go ahead and click on Map. So click on Map. And if you've, I should also preface this as the reason why, I should have mentioned this early on in the video, the reason why we're spending the first 2 weeks of class on ArcGIS Pro is because not everyone in Geography 231 has used Pro yet. I know if you are coming from 232, you certainly have, but if you're coming straight from 230, you may not have. So that's why I wanted to take some time specifically just to learn the software itself, not to jump right into spatial statistics and spatial analysis. Because we will be using ArcGIS Pro for the entirety of the class. So we'll spend a little bit of time on ArcGIS Online, but we will not be using ArcMap. So I want to make sure that everybody has the same kind of baseline level of comfort with ArcGIS Pro. It's a really good program, but there is a bit of a learning curve if you've never used it before. So with that said, we're going to go ahead and name the project LA River Park Site. And I'm going to add mine a number 2 because I've already done this tutorial to kind of practice it. And so I already have one called Park Site, but you don't need to have the number 2 there. And you're going to save it in the default folder where the data that you downloaded from Canvas, where that was saved. Okay. So that will be on your C drive in the Esri Press folder / UGIS4. Okay. So UGIS4, so you literally just select the UGIS4 folder. You don't need to double click to get into it. All right, and this is just kind of another quirk of ArcGIS Pro. So what you're doing is you're selecting the project location. You're not actually giving it the name here. You're giving it the name in the name box above. So just select it one time and hit OK. So we're creating a new project called LA River Park Site in your case, in the UGIS4 folder. Then you go ahead and hit OK. For it to load up here. Okay, so on our left-hand side, we have the contents pane. If you're coming from ArcMap directly, this is called the table of contents in ArcMap. In ArcGIS Pro, it's just called the contents pane. On the right, we have a catalog. It's known as ArcCatalog in the ArcGIS world. In ArcGIS Pro, it's just called catalog. But this catalog has a few more connections than what you may be used to in the ArcGIS version. Okay, so we've got connections to databases, different styles, toolboxes, and maps. We'll get into that in a moment. All right. Now we're going to open the catalog pane if it's not already there, and it is visible on the right-hand side. And we're going to rename this map. So we just created a new project called LA River Park Site. And every new project has a default map that's created. You can see it on my screen right now. And this map also has a record here in the maps folder. But map is a fairly generic name, so we are going to rename it to Lesson 1A. Lesson 1A. Enter. Okay. And this will come in handy later on once you do Lesson 1B as well. We'll just copy this project and create a second version. Or copy this map and create a second version. All right, so we rename that. Next thing we're going to do is change the base map, and we do that under the Maps tab. And I would be remiss if I didn't highlight the fact that ArcGIS Pro uses what are known as tabs and ribbons. So we've got Map, Insert, Analysis, View, Edit, Imagery, Share. Okay, these are the default standard tabs. You also have what are known as contextual tabs, which I'll get into later. And I believe they're mentioned in the lecture as well. So Just know that these are obviously highly different than what you see in ArcMap. All right, so under the Map tab, under Base Map, click the arrow, the drop-down arrow, and choose Streets. All right. Then notice now we've got a record of the base map here in the contents pane. Okay. Moving forward, next thing we're going to explore is the Explore tool. So the Explore tool has more or less replaced the pan zoom tool from ArcMap. The cool thing about it is that yes, you can use it to pan around, you can use it to zoom, but you can also use it to identify. And I don't have any vector features here to identify yet, but the little finger there, if you click on screen, if you had a vector feature, you could actually identify the feature. If it was a polygon of cities, it would tell you the city name. If it was a polygon of rivers, like we'll deal with in a little bit, it'll tell you the river name. So the Explore tool is actually quite a big advancement from what was in ArcMap. Okay, so I just want you to spend a little bit of time kind of panning and zooming around the United States just to kind of get used to the Explore tool. If you hold down the Shift key, you then have the magnifying glass there, and you can draw a box around where you want to zoom in. We want to zoom into Greater Los Angeles. So we are lucky in that this textbook uses LA as a subject area, and we presumably live in Southern California. I know I do, and most of you Cypress College students do. There may be some of you coming from farther afield, but we get to work within an area that's in our backyard here. So that is lucky for us. Okay. So zoom into Los Angeles. You have several different. Next thing we're going to do is add a layer to the project. So these concepts should be familiar to you. Now, obviously, the interface is going to be different if you've not used ArcGIS Pro before, but the concepts of adding vector data and raster data to a map, using the Add Data button, using catalog, panning and zooming, these are all concepts that you've obviously already been exposed to in ArcMap. So I hope that sort of helps smooth the learning curve a bit, that these concepts they're not new. There's just a new way of doing them. So at any rate, we're going to now add our first vector layer to the map. And so there are multiple ways to do it. You can click the Add Data button, or like we're going to do now is we're going to add a folder connection. And that will be a direct connection to a folder containing a geodatabase. The geodatabase contains spatial data relevant to this project. So you're going to right-click on Folders in the Catalog pane, Add Folder Connection. We're going to go back to Esri Press, UGIS 4, make the connection directly to the ParkSite folder. So just select ParkSite. If you need to go back, you just click it up here to go back. Then hit OK. So we've now connected to the ParkSite folder. Within the ParkSite folder, we have maps and more, and we have data sources, or excuse me, source data rather. So we're going to maximize source data, and then we are going to maximize this Esri geodatabase. And within the Esri geodatabase, we have 4 feature data sets: boundaries, hydrology, landmarks, and transportation. Right now, we want boundaries. We're specifically looking for city boundaries. And so we're going to choose this city_PLY, that's city polygon. And we're going to drag it and drop it on the map. All right. So when you do that, when you drag it and drop it, you realize that it zooms out to the whole United States extent, and it's every single city in the U.S. All right. I believe it excludes unincorporated communities, what we call CDPs. It's only incorporated cities, but it's a lot. It's quite a few. And you can see, obviously, there's a higher density of cities on the East Coast, a lower density on the West Coast, but we have some large cities in Southern California, including Los Angeles, which is the subject of this project. So one thing we need to do initially is just kind of familiarize ourselves with the contents pane. So you can turn a layer on and off. You can change the symbology, which we'll do together. But the contents pane operates the same way as the table of contents does in ArcMap. Okay. All right. We're going to set layer properties. So let us change the color of the city boundaries, and multiple ways to do it. But initially, we're going to right-click on the color chip right here, and you'll get a color selector here, ArcGIS colors. The color that we want is olivenite green. All right, olivenite green. So if you have the textbook, there's it shows you where it's at, but you can just kind of follow along. If you see my screen there, it's kind of center left, about the center row, and it's kind of an ugly yellowish greenish. Go ahead and select that, and that's going to change the color for every single city. And let's zoom back into LA so we can stay focused on our area. You could always hit the previous extent button as well once you zoomed out to the United States. Okay. All right. Next thing we're going to do is change the name of city_ply to just cities. Okay. So to do that, there are multiple ways. If you remember from ArcMap, you can click the layer name, then hover your cursor over it, makes it editable. You can change it that way. The way the textbook has us do it is we're going to right click, go to Properties, and then under the General tab, we're just going to get rid of city_ply and enter cities. Okay. And then we can go ahead and, while we have it open, we'll go on to looking at the source data. If you click on the source tab, you can see where it's located. It's on my C drive, /esripress, /UGIS4, all the way over into the Esri Geo database, and the feature class name never changes. You don't actually change the name of the feature class itself. You can change the name as it displays in the contents pane, which is what we just did. Okay, so go ahead and hit OK. All right. Next up, we're going to get some information about this data. So as you see on screen, there are a whole bunch of polygons here, and any one of these has plenty of attribute data associated with it. So we're going to use that Explore tool and just kind of click around the map. And the first thing we see is what we call a pop-up. So I've got two monitors, and I notice like my pop-ups are popping up on the other screen. So if you ever see something not happen instantaneously on my screen, it's because it probably popped up on the other screen. So I have to drag it back in. All right. So this is the pop-ups menu. Anything you click on screen will then update in the pop-ups menu. You can see the big polygon here is the city of Los Angeles. In the pop-up, it tells you the name, the class, it's a city, the FIPS code, the population in 2010, 3,792,621, and then the population per square mile, over 8,000 people per square mile. That's quite a high density of population. And to come up with that, you just take the total pop divided by the square miles. So 3.7 million divided by 472 comes out with around 8,000 persons per square mile. So whichever city you select, here's Anaheim, we'll give you the population, 336,000. Here's Long Beach, if you live in Long Beach, 462,000. While we're at it, let's find Cyprus. There's Cyprus. Population 47,802. Square miles about 6.5. So pretty high pop densities, 7,253 people per square mile. So pretty high pop density. All right, so we'll go ahead and close that. And then this will be a bit more familiar to you if you're coming from ArcMap, the attribute table. And right-click the layer, open attribute table. Then you'll notice that across the top, all of these field headers have a corresponding entry in a pop-up. So name, class, state, name, class, state, state FIPS, place FIPS, housing units, state FIPS, place FIPS, housing units. So everything you see in the pop-up is also in the attribute table. And so if you format something in the attribute table, like maybe it's a numerical value, you want to add a comma separator for thousandths place, you can do that, and it'll show up in the pop-up as well. Okay. All right. Moving on. Next thing we're going to do is right-click the. Let's see. We've actually already done this. So probably we'll just do it real quick. So if when you added in the cities layer initially and it didn't zoom out to the whole U.S. level, we'll just quickly do it together. So right-click on cities, click on zoom to layer. Now you can see the full extent again. Mine happened by default, but maybe yours didn't. So the book has you do that. And once you do that, just go ahead and click on the previous extent button. It'll bring you right back to where you were before. And let's close the attribute table so we get the whole map on screen. All right. Okay, so we want to select Los Angeles. So there are two different ways to select Los Angeles. You can either use the select tool, select by rectangle, which is the default, or there's other selection methods, and we can just click it to select it, which is what I've just done now. Or if you have the attribute table still open, you can also you can select it that way. So you can either do a select by attributes and find city equals Los Angeles, or the quickest way is we know that LA is the second largest city in the state, excuse me, in the country rather, second largest in the country behind New York. So if we click on POP 2010 and we sort descending, so from largest to smallest, LA should be the second record here. And sure enough, it is. Okay. So we've got New York, LA, Chicago, Houston, Philly, on down. All right. So that's another way to select the features just through the attribute table, which shouldn't be new information for anyone. All right. So we've got it selected. We are then going to zoom to LA. So you can do it this way by clicking zoom to, or if you close the attribute table, you still have it selected. You can right click on the layer in the contents pane, selection, zoom to selection. So there are different ways to do that, but that's what we want to do now. Zoom to LA and then clear selection once you've done that. All right, next task is to definition query out only the city of Los Angeles. So we're going to get rid of all their cities. Multiple ways to accomplish that. You could delete them, but we don't want to do that. All we want to do is set a definition query so that city name is equal to Los Angeles. How do you do that? With a definition query, just the same as ArcMap. But the way you get to it, it's the same way, but it's the way it's organized a little bit different. So we're going to double click the layer name, or you can right click, go to properties, click on definition query. So if you're coming from ArcMap, you know that these were tabs across the top of the properties box. In this case, now they're organized vertically instead of horizontally, but many of the same things are there. A key difference, though, is the definition query interface. So instead of relying solely on SQL, in this case here, it has kind of a more user-friendly interface, which I like, actually. But if you are old school and you want to use a SQL definition query, you can do it like that and just go city, or in this case, what's it called, place, name equals Los Angeles. But we're not going to do it this way. Okay, so we're going to hit cancel, and we're going to delete this one. We're going to do it the way the book says, and that's with the new system. So just go ahead and click on new definition query. We're going to do it this way. So it says where, and then the field name, where name is equal to, which is the first option. It could be something else, begins with, ends with, whatever, is equal to, and then remember, this is every city in the United States. So rather than scrolling through a massive list of cities, we're just going to type in Los Angeles. So where name is equal to Los Angeles, apply. And then OK. And now we only have one city left, and it's the city of Los Angeles. All right. OK. Let's see here. Next up, we're going to add another layer to this map. We're going to add a rivers layer, okay? Because, as I mentioned at the very beginning of this tutorial, this whole project is premised on the idea that the Los Angeles River needs to be revitalized. If you've read this beginning of the chapter, you'll know that the LA River has a long history. It was flooded in 1938. They decided to channel it, and which has created the kind of the eyesore of the LA River that we have today. So the city of Los Angeles and the county of Los Angeles have been working together to beautify the area around the LA River. And so many parks have already been built. More will be built in the future. But this book is premised on the idea that there is room for public input. So you as a GIS user could actually put in some criteria and maybe make a recommendation to the city of LA. Like, Los Angeles, look, these various criteria are met, so you might consider building a park in this location. So that's really what we're going to do. So in order to be able to identify the prime locations around the LA River, we need to add the LA River to the map. So let's go ahead and do that. So again, just like an ArcMap, you can either click the Add Data button, or as we're going to do now, we're just going to go back to the Esri geodatabase, and then the Hydro feature data set. We're going to take river and drag it onto the map. Now, you will obviously notice that it's not just the LA River, it's many different rivers. Oops. It's all the rivers in LA County, okay? And you probably didn't realize there were this many rivers in LA County. I know I didn't, but this is essentially, it's more about the hydrography of the area. It's not necessarily the actual rivers. So most of these are intermittent. Like in a massive rainstorm over the San Gabriel Mountains, we might see little creeks forming that somewhat represent what you see on screen here. This obviously is not a representation of every river in notoriously dry Los Angeles County. All right, but that gives us something to begin with, and then we're going to pare down this large data set into just the LA River, and we're going to do it the same way we did before. So first things first, let me just show you, if maybe you already know where the LA River is, but It happens to be this, oops, that's the city of LA. You're going to run into that issue identifying features. There you go. There's a portion of it. So it gives you the name, Los Angeles River, the type, stream or river, description, perennial, and we're going to come back to that in a little while. And then a segment. The segment of the river there is 33,000 feet long, right? So quite a few miles. Okay, so there's the LA River right there. Now let's query it so only the LA River is visible. So we're going to go back and do the same thing we did before. Open up the attributes, in this case for the rivers layer, new definition query. We're going to go name is equal to Los Angeles River. Name is equal to Los Angeles River. Apply, and okay. There we go. That's a little easier to digest visually, isn't it? So there's the LA River flowing through the city of Los Angeles, then kind of veers out and goes down more or less parallel to the 710 freeway, and then dumps out in Long Beach. And I lived in Long Beach for some time, so I'm well familiar with the LA River running through Long Beach. I'm sure some of you are too. Okay, so we have queried it. Next thing we're going to do is symbolize it, because I actually got lucky and my river is blue, but as you may or may not know, symbology on a new layer is randomly generated. So you might have a purple river or a pink river or a black river. Okay, so we're going to color it so it looks more like what we would expect to see of hydrology on a map. So we're going to click it. In this case here, don't right click. You're going to left click like a typical normal click here on the river, and that's going to open up the symbology pane. Now, symbology and the word appearance are used interchangeably often. So appearance is kind of a new addition to the ArcGIS Pro world. We didn't really use that term in ArcMap, but symbology is a term that you're familiar with. So appearance and symbology, sometimes if you're looking for symbology, you might see the appearance tab. That's actually what you want, okay? So we've got the symbology for the river here. We're going to click on properties. We're going to change it to a blue that the book doesn't specify. I like Cretan blue, but you can choose whatever one you want. And then we're going to do 3-point thickness to really make it stand out. All right, so there we go. Now we can see that much more clearly. All right, so we've got our river. We can now close the symbology pane there. Okay, so LA River, City of Los Angeles. When we look at the LA River, it looks like a single feature. Essentially, it looks like we've got two individual features on screen. One is for the City of LA polygon, and the other one is for the LA River polygon. The reality is that the LA River is a collection of multiple segments. It's not one single river, it's multiple segments. And that's actually for a GIS reason. So when you've got multiple lines intersecting one another, the lines often stop and then a node is created. So essentially think of it like as an intersection. When multiple roads cross, they create an intersection, right? And so the end result is all of the various tributaries to the LA River, every time they intersect the LA River, it creates a break in the line, a new segment, and then it continues on south or north or east or west of that intersection, okay? So the end result is, if we open up the attribute table, we're going to have something like 17 segments. Yes, 17 segments of the LA River. So these were all queried out because they all had the same name, but technically it's 17 separate features, not one single feature. Okay. All right. So you might notice in the description field, we've got 3 different descriptions. Is it 3 or 4? 3. We have artificial path, intermittent, and perennial. So you probably can figure out what all 3 of those mean on your own, but just to sort of spell it out for you, artificial path, I feel like that's a bit underutilized because so much of the river is channelized through concrete channel. So I feel like a lot of it is actually an artificial path, but only one segment, and that specifically brings you down to the mouth of the LA River in Long Beach. Only one segment is considered artificial path. 4 segments are intermittent, and then the remainder, 12, are considered perennial. So if it's a perennial river, it means it's always there. It's all throughout the year, there's going to be some water in there. And that may not necessarily be the case with the LA River. There may be times when it's so dry that it's just a trickle. But in theory, with all the various tributaries, there should always be some bit of water. Now, 4 segments of this, and I won't show you where yet, are considered intermittent. And those truly do dry up frequently throughout the year. And they really only get water, river water, during a rainstorm. Okay, so that's the reason why those are labeled as intermittent versus perennial. So let's find out what parts of the river are perennial and what parts are intermittent. So what we're going to do is click on select by attributes. Okay. going to select by attributes, and then we are going to make sure that our input row is set to river, which it is, and we're going to do a new selection. All right, so the default selection type is new selection, and we're going to create an expression, just like a definition query. So what we're looking for is parts of the river that are perennial, always there. So we're going to go to description is equal to perennial, and go ahead and hit apply. And for now, we can close this select by attributes box, and notice we have 12 segments. All the perennial ones are selected, and then I'm going to just shrink my my attribute table there, and then I'm going to make sure that you can see all the portions of the LA River that are perennial. Most of it, right? Most of it has some bit of water throughout the year, but not all of it. Obviously, the intermittent section is up in the top, and then the channelized portion is down there in Long Beach. Okay, so that's that. Okay. Okay. Next task we're going to accomplish is finding out how specifically what length of the LA River is categorized as perennial. So the entire LA River from north to south is about 50 miles long. All right. I actually had to stop and check. So the whole LA River is about 50 miles long. So we're going to find out what portion of that 50 miles is a perennial stream or perennial river. All right. So to do that, we're going to use the Summarize Statistics tool. All right. So Summarize Statistics. So let's go ahead and open up our attribute table once again, or maximize it if you shrunk it like me. And we are going to right-click on Description and click on Summarize. So what this does is it basically kind of runs like a dissolve. If you remember back in Geography 230, you probably learned about the geoprocessing tool dissolve. What you can do when you dissolve is not only combine like features into a single polygon or a handful of polygons, you can also summarize their statistics together. So if you've got all cities in LA that have populations over 100,000, you want to merge them into one single polygon, you could do that, and then you could add up all of their populations as well. Okay, it's kind of one example. Okay, so this way we're not actually changing any of the geographies, the actual geometry of the features. We're just going to take that data and do sort of an addition. We're going to summarize the data to find out what the total length is. So we're going to take the info from that feet field, we're going to add them all together, and we're going to then find out. Okay. All right, so input is river, obviously. The default output table is called River Statistics. We're going to change that to LA River Perennial. LA River Perennial, no spaces. Okay. And notice how I just clicked in this box. I clicked in the box. Like right now, you could obviously, if you're coming from ArcMap, you might want to click Browse. That's the standard way to do it. But in Arc Pro, you can just put your cursor in there. Then it will show you the path of where the file is going to be saved. And all you need to do is back up to the final backslash. And from that, just to the right of the backslash, you can enter the text there. Okay, so that's what I did. LA River Perennial. And then the statistics field, we're going to do this on feet, right? Because we're going to be adding all the feet together. And the statistic type is going to be sum, so we're going to leave it as is, but know that there are lots of different statistical types that you can apply here. And then verify that the description field is the case field. The case field essentially is more or less like what the dissolve field would be. And so if we want to find out the length of all the intermittent, all the perennial, and all of the channelized, I can't remember what the field's called right now, the type, but you would do this, use the description field. So it'll essentially give you three different types because there are three different data entries in that description field. All right, so we're going to go ahead and hit OK, let it run, and what it does is it creates a table. Over here in the contents pane, we now have a standalone table called LA River Perennial. We're going to open it up, and we have the perennial field which we chose. You could also have added in the other two as well. So we have 12 segments for a total of 229,000 feet. So 229,000 feet. That's, what is that, about 45 miles maybe? Let's see what that is. 229, 5,280, 43 miles. So 43 miles of the 50 mile length is a perennial river. Okay. So we've got that information now. Now the last couple of steps I'm going to do with you in this tutorial are adding labels to features. And actually, I think you'll do labels on your own. I think we do labels in the next section. Not labels. We're going to change the base map, and we are going to create a bookmark. So we're going to change the base map, create a bookmark, and then you'll do the rest on your own. Okay. So on the Map tab, we're going to change the base map. Map tab, go to Base Map, and we're going to change it to Imagery with Labels. And what this allows you to do is utilize satellite imagery. You can actually see what a satellite sees of the ground. Okay, we can close that the tables there. Close the both attribute tables, and let's clear our selection for now. Okay. So we changed the base map there to imagery with labels, and we're going to also create a bookmark. We're going to create a bookmark for the city of Los Angeles, so that way we can zoom back to it, because you're going to be zooming in quite a bit, looking for park areas, and so it'll always be handy to be able to zoom back to the full extent of the city, and the easiest way to do that. There are multiple. You can either right-click on cities and zoom to feature, which, I think I missed a step now I'm thinking about it. We should have changed this to Los Angeles. I trust that you students already knew that. Okay, so we're going to create that bookmark. Okay, so let's first zoom to the city. So we can select, zoom to layer. Okay, and then we're going to go to bookmarks, new bookmark, and we'll just call it City of Los Angeles. Enter. So now if you zoom in, so you want to check something out, blah, 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 blah. I want to go back. You can just go to bookmarks, City of Los Angeles. Okay. So that's pretty quick and easy. And then I will actually sign off for now. I think you've listened to me talk long enough. We're coming up on 40 minutes. And so you will need to now complete the rest of exercise 1A and all of exercise 1B on your own. To get credit for this first lab, essentially what I want from you is a PDF map uploaded to Canvas that shows the area around Dodger Stadium with the census tracts symbolized the way that the book has you symbolize them. Okay, so you're going to see once you get through section 1B, you're going to have all these various census tract data symbolized based off of population density. Okay. And so it's going to be basically pop density, high, medium, low. And so I want a PDF map. And if you look on page 57 of the textbook, you're going to see an example. Okay, it's not actually a layout. At this point, I don't necessarily need you to get into adding the map elements like the north arrow, the scale bar, the text boxes, things like that. All I need is a PDF that shows me the area around Dodger Stadium with the Elysian Park to the north, census tracts around, and using page 57 as an example. So you're going to, in order to create a PDF, while we're here, you're going to make sure that you're on the Share tab and then Export Map. So just have to kind of imagine on my screen that it's already up there. But you click on the Export Map there, change the type to PDF, save it locally on your computer, and then upload that PDF to Canvas. Okay, and I will trust that everyone will be able to pull this off in a week. This is essentially, I would say this is probably about 3 hours worth of work, tops, if that, even if you're new to ArcGIS Pro. Just know that this lab work is designed to be finished in class. So if we were meeting 2 nights a week, Tuesday, Thursday from 6:30 to 9, we would be able to knock this out together. Okay. And so I will never give you anything that you can't finish within a week. The readings are homework, so obviously that doesn't really count for that 2.5 hour lab time per night. So there are going to be weekly readings, not every week, but most weeks. And it's never going to be more than like 30 or 40 pages. You got to be able to knock that out within a week fairly easily. So at any rate, in order to get credit for this lab, like I said, create a PDF of the area around Dodger Stadium, upload that to Canvas. And the way I have my naming format that I prefer students use is your last name _ week whatever. So this would be like my last name Bowles _ week 1. That's really all I need from you. If it's multiple assignments, like if there's more than one PDF, Bowles _ week 1 exercise 1A, bowls underscore week 1 underscore exercise 1B, that sort of thing. So something just to differentiate it, but make sure that your last name goes into the file name first, so I know who's submitting what. Okay, so that ought to sum this up. If you have questions, reach out to me via email. We can always set up a Zoom session to chat, or hammer things out via email, or you can also post on the Canvas message board, the discussion board, or you can send me a message through Canvas as well. A lot of ways to get in contact with me. But I am looking forward to the semester. I think we're going to have a fun time together, and best of luck. All right, take care. Bye-bye.